Welcome to Will Rogers World Airport Fire Department. There are many types of firefighting foams. Firefighting foam is foam used for fire suppression. Its role is to cool the fire and coat the fuel, preventing its contact with oxygen, resulting in suppression of the combustion. AFF concentrates, when proportioned at the appropriate rate, form a vapor suppressing seal for rapid control of hydrocarbon fuel fires. AFF concentrates require low energy input to produce a high quality foam blanket that floats on and quickly covers the fuel surface. AFF is intended for use at the proportioning rate of 3% on Class B hydrocarbon fuel fires. To accurately test AFF, you must utilize a conductivity test kit, as AFF cannot be tested with a refractometer. Periodic sample testing is a necessary step in ensuring that AFF fire suppression foam continues to perform as required for its specified applications. In this demonstration, we will be utilizing the CHEMGUARD Precision Foam Solution Test Kit. It allows fire protection professionals to determine the proportioning accuracy of fixed foam systems, mobile foam systems, and portable foam equipment. What's showing now is a complete testing kit. The kit includes all the components needed to test discharge foam solution. At Will Rogers Fire Department, we utilize two unique components to facilitate the collection of foam samples: a catching system and 3 separate containers to hold the foam that will be tested. Collect water and foam from the apparatus to be tested in a container. Make certain the water is allowed to run long enough that only clear water is flowing and that the foam concentrate is not diluted. Use the water and concentrate samples to make up 3 standard solutions using 3 of the 150 milliliter beakers provided with the kit. The standard solutions should include 1 at the nominal or desired proportioning percentage, 1 at the nominal percentage plus 1 or 2 percentage points, and 1 at the nominal percentage minus 1 or 2 percentage points. The following demonstration will show a collection from the roof, bumper, and handline discharge. As a side note, if the apparatus being tested is equipped with under-truck foam discharges, this will require a forced sample. When collecting the foam mixtures, be vigilant and try to conserve foam during the sample collection period. A 3 to 5 second flow allows time for maximum solution mixture. It's also important to clean any equipment used during sample collection to prevent cross-contamination of samples. Remove the electronic scale from the case and place it on a stable flat surface. Turn the scale on by holding down the on-off switch for approximately 3 to 5 seconds. Allow the scale to warm up for at least 30 seconds before use, then check that the small arrow on the right of the display indicates the scale is set for grams. If not, toggle the unit button to grams. Place a calibration weight on the scale and see if the display shows 100.0 plus or minus 1.0 grams, then remove the weight. Place a clean 150 milliliter beaker on the scale. The scale should display 11.7 grams unless it has already been zeroed. If not displaying 0, depress the 0 button on the scale until the scale reads 0.0. Now that the scale is calibrated, you will transfer the samples from the filled collection containers into the beakers for testing. Use one of the syringes provided to remove concentrate from the 125 milliliter concentrate bottle. Carefully add concentrate from the syringe to the beaker on the scale until the scale indicates 3.0 for 3% foam solution. Fill a 100 milliliter graduated cylinder with approximately 90 milliliters of water from the sample taken from the apparatus and pour it into the beaker. Use care that the scale reading does not exceed 100. Remove the beaker from the scale and carefully pour the contents into one of the clean 150 milliliter beakers. Pour the sample back and forth, beaker to beaker, 3 to 5 times. Being that the nominal percentage for this conductivity test is 3%, the additional samples are made at 2 and 4%. Remove the cap from the conductivity meter and press the on button until the unit comes on. The display should indicate 0.0. Allow the meter to warm up for 1 minute. Place the measuring end of the meter into the lowest percentage solution and allow the reading to stabilize. Just like collecting the samples in the field, it's important to clean the conductivity meter between sample readings to prevent cross-contamination. Record the reading from the meter and the percentage of the sample in the space at the top of this form. On the conductivity chart, mark along the spaces at the bottom of the percentage range of the samples. For 3% foam, you may want to mark your lowest sample, 2%, then 2.5, 3%, 3.5, 4%, and 4.5%. Along the left side of the chart, mark the conductivity range of the samples. If the sample has a reading of 2%, or 0.75, 3%, which is 1.10, 4%, 1.45, you may mark the spaces from the bottom up as 0.25, 0.50, 0.75, 1.0, 1.25, 1.50. Using the straight edge, mark a vertical line above the percentage of the lowest, the nominal, and the highest samples. Again, using the straight edge, mark a horizontal line indicating the meter reading for each of the samples using the scale on the left edge of the chart. Draw a circle at the points of intersection for each of the samples at 2%, 3%, and 4%. Use a straight edge to draw a line connecting the 3 points. There are many types of foam testing kits. Please follow your department's guidelines and procedures to performing a conductivity test. Always remember to be safe and have fun testing.